Check this out. We've got something really fun today. This is so amazing, man. Oh man, again? Let's warm up by talking about what Carl Friedrich Gauss did in 1777 when he was just 10 years old. His teacher asked the class to add all the numbers from 1 to 100, and the teacher thought that they would just add them separately and it would take them a long time. Everyone was really surprised when he was able to come back with the answer in just a couple of minutes. So what was the answer? Well, he may have done something like this. We're not entirely sure what he did because he didn't write down his approach, but it was something like this. He realized that there was a pattern here, and if he took all the numbers from 1 to 100 and then added all the numbers from 100 to 1, you see that 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, and then the same thing on this side. Now, this is a nice pattern. How many of these do we have here? So we had 100. You can see from the first line here, we had 100 terms, and we add it together and we get 100 101s. So I can say 100 times 101 is equal to 10100, or 10,100. Now we do have a little problem here, and that's we've got twice as many as we want because we just wanted this here, the sum of 1 through 100. We didn't want it twice, so I'm going to take this and divide by 2, which is not that hard to do, and we get that half of 10,000 is 5,000 and half of 100 is 50. So we get the answer is 5,050. Now he may have used more visual approach, and this would also work. If I take all of these things here, this is obviously not 1 to 100, that would be too difficult to draw. But if I took this little one here and put it on top here, okay, then I took these two here and put it here, and then these three and put it here, and you can see that instead of this staircase shape, we've just made a rectangle. And we can find the area of this by multiplying the base times the height. 1.2, Arithmetic Series. A series is the sum of a sequence, or adding up all the terms in a sequence. Therefore, an arithmetic series is the sum of an arithmetic sequence. We're going to use capital S with a subscript to denote series here. So the series up till term n is all the terms added up until the nth term. Now if we had something like this, S subscript 50 here, or a series 50, then we'd have to add up all the terms to 50. But we don't want to be doing that. That's a lot of work, and we're likely to make a mistake. So there must be a formula here to help us do this. Let's see how we would derive the formula for an arithmetic series. Remember, the series is all the terms added up till the nth term. And we can also write this a different way. If we have term 2 here, term 2 for arithmetic series is term 1 plus the common difference. Term 3 is term 1 plus 2 common differences. Now once we get to this side, we're going to do it opposite. We've got Tn as the last term here, and we're going to add the previous term, which is Tn minus the common difference, and the term before that is Tn minus 2 common differences. And now that we have it written like this, we want to add this, just like Gauss did, with the terms in ascending order and then the terms in descending order. Now you notice something when we try to add this. We're going to get 2 of these, and we don't want to, but we'll deal with that in a minute. And you notice that we got a plus d here and a minus d here. And the brackets, there's no coefficients, so the brackets are just here to keep everything organized. So this and this will cancel out. Same with these two. Plus 2d and minus 2d are going to cancel. All of these will cancel throughout this whole thing, and we don't have any more d in here. Let's see what we do have though. We've got t1 all the way through. Okay, so how many t1s do we have? Well, in this one, we don't know. We just have n terms. So we'll just say there's n t1s. Now the same thing with tn's. There's a tn, 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 all the way through. So we also have n tn's. Hopefully that looks like a plus sign. Now, we just want to divide both sides by 2, and most often this is written when we factor out the n. So this would be 2Sn equals n t1 plus tn. Now we divide both sides by 2, and we get this formula right here for our arithmetic series. We want to add up all the numbers from 1 to 9. So we're trying to find S9. So let's write out our equation. S9 is equal to 9 is our n here, t1 plus t9 divided by 2. Now let's put in these terms that we know. So S9 is equal to 9, t1 is just 1, t9 is just 9, and then we're going to divide by 2. And when we evaluate this, we get 9 times 10 is 90, divided by 2 is 45. Now let's look at this visually. So I made a visual representation of this series. Here's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. And it's important to see that this equation here can be thought about as if we are taking these, moving them down, taking these, moving them down, taking these, moving them down, and taking this last one and moving it down here. Now when we do that, we're actually finding the average. So this term right here, this is our n, and this represents the base of the rectangle. Okay, so from here to here is n. Now the height of this rectangle will be the average, so t1 plus t9 divided by 2 gives us our average, and that would be this height here. So this would be t1 plus tn divided by 2 is the average. Example 2, we're given this series here, and we want to determine S50. So S50 is equal to 50 t1 plus t50, and you see a problem here. We don't have t50, so we're going to need to go find that. T50 is equal to t1 plus 50 minus 1 common differences, but we don't have that common difference, so we're going to have to go find that. So the common difference is 7 minus 3, and that's 4. So finally something we can solve. Bring this back, put it in here. So T50 is equal to our first term, 3, plus 50 minus 1 is 49. Common differences is 4. Now we can actually evaluate the 50th term, and it is 199. So now we can use that, bring it back here, put it in our equation. So we got 50, we have term 1, now we have term 50, and now we can evaluate S50, and it is 5,050. We can derive another formula when we don't have the nth term, and that is just subbing in the formula for the nth term into the series formula. Okay, so when we replace Tn with all of this stuff, then we see that we have two T1s, and we can combine them up. And this is a new formula, and it doesn't contain the nth term. It only depends on the first term, which usually we're given, so it's pretty helpful. Let's go back and try example 2 with this formula. We will still have to find the common difference using this formula, but after we found that, we'll just jump straight into finding S50. So 50 is n here, because that's our subscript there. And T1 is still 3. And the common difference is 4, as we found there. Now we can just calculate this, and we get the same answer. We get the S50 is 5050. Example 3, we're given this series. We're not given the 100th term, so we'll use the second formula here to find S100. Now you notice we don't have the common difference, so that's something we're going to have to find here. So that is 1962 minus 2004 gives us a common difference of negative 42. Now let's plug everything in that we know. So n is 100 here, and 2 times T1 is 2004 plus 100 minus 1, common differences is negative 42. I'm going to put in brackets so it doesn't look like minus 42. Close that bracket, and actually I can just put this in my calculator, watching out for the brackets here. And I get negative 7,500. We want to determine the sum of all of these terms here, but we don't actually know how many terms there are. So the first thing we need is n. Let's find that using our Tn equation here. And we know T1 and we know the nth term, whatever that n is. So the nth term is 49, T1 is 13, and we don't know n, so I'm going to leave that here as my unknown. And we need the common difference. So d is equal to 15 minus 3, so d is equal to 2. 2 here. All right, now we just do some algebra here and solve for n. So maybe minus 13 on both sides here. Get rid of that. We've got 36 is equal to 2n minus 1. Divide both sides by 2. We get 18 is equal to n minus 1 plus 1 on both sides. And n is equal to 19. Now we can actually find the sum. So there's going to be 19 terms here. So 19 T1 plus T19 divided by 2 here. And we get that the sum of all these terms is 589. This was part of Relations and Functions 9, analyzing arithmetic series. Here's some questions. Try them out. See if you know what you are doing.